question number 11. A pendulum of length L oscillates with angular frequency omega. The mass of the pendulum is doubled. Mass of the pendulum is doubled. L dash becomes 2 times L. Mass of the pendulum M dash becomes 2 times M, and its length is changed to L by 4. L dash is equal to L by 4. What is the new angular frequency of the pendulum? Now, first to get the angular frequency, first find out the actual frequency. So we know that time period of oscillation T is given by 2 pi into square root of L by G. So what is this now? 2 pi. So now if I want to find a new pendulum, T dash will be equal to 2 pi into square root of L dash divided by G. Okay, it does not depend upon mass, depends only on the length over there. So it should be 2 pi into square root of what is L dash? L by 4 divided by G, which should be 1 by 2 times I'll write this as 1 by 2 times 2 pi into square root of L by G. How do I get 1 by 4? Square root of 1 by 4 is 1 by 2. I took it outside. I get this value, which is equal to T by 2. T by 2 again. Okay. So therefore, now if I take frequency as I know, F dash is equal to 1 by T dash, which is equal to 2 by T, which is equal to 2 times F. Right? Because 1 by T was F, 2 times F. So what has happened? The angular frequency is doubled. Say linear frequency is doubled. What is angular frequency? Omega is given by 2 pi f. So therefore, omega dash would be given by 2 pi f dash, which is twice the omega. Okay. So the value omega dash is equal to twice of omega. The correct option is C.